just going to record this on from Tom Hartman. There's some information about the Fukushima official, but I'll just leave that going on in the background with playing so you can hear it. And I just want to show you this map, so you can just take a look at this map. Here you can see Tokyo, and then this is obviously the northern hemisphere looked in from above, and there's you can see the predominant wind travel. Los Angeles there, Vancouver, Mexico City, and then here's the Britain, Ireland, Europe, Moscow, and obviously there's Africa, north part of Africa there. And as you can see the path of the wind, and I'm not sure where this mapping is coming from precisely, but presumably this is the radiation flow. I imagine, but anyway, it's certainly the predominant wind system, and you can see straight across us, it's coming straight across the whole of the United Kingdom there. So I'll just leave that playing.
Well, the Japanese government has now come out and said Fukushima Daiichi is the nuclear disaster that happened there is a 7 on a scale of 1 to 7. I think maybe pretty soon they're going to have to take this to a scale of 1 to 10. I'm not sure where the scale came from, and if it's linear or logarithmic or what it means, but let's check in with somebody who probably knows and what the consequences of this are. Our old friend Paul Guntner, the director of the Reactor Oversight Project at Beyond Nuclear, beyondnuclear.org, the website. Their Twitter is at Beyond Nuclear. And Paul, welcome back to the program.
Thanks again, Tom.
So in any case, Paul, what's the difference between a 5 and a 7? Who came up with this scale? What does it mean?
Well, it's the International Atomic Energy Agency that came up with it, but these guys are a promotional agency. They're as interested in building barriers to understanding as they are the radiation that this terrible industry has released on the planet. Again, this 7 has only one reference point right now, and that's Chernobyl. Now now we've got 2, but it's clear that you have an accident that's ongoing. So we've got rivers of radioactive water building up inside these plants because the cooling systems don't work, and they have to inject water in an effort to, they're going to simultaneously try to rebuild some of these pumps. But that river is, threatening to flood again into the Pacific Ocean. So it flushes these 4 reactor pools and 3 reactor
cores.
Buildings and cores are flushing out, and so this is a Chernobyl to the sea. Mm-hmm. And it is vastly different, as Chernobyl was different from 3 Mile Island.
Now, when I lived in Europe the year after Chernobyl, and the big problem, of course, was that the prevailing winds, which typically are east to west or west to east rather, had kind of flipped around, and they picked up the Chernobyl radiation and took it first up over Scandinavia and then back down over the rest of Europe. I know it came over Germany because I lived there. And then kind of looped back around again and started going back east the way it's supposed to. And so this fairly wide area was contaminated. The Soviet Union at first kind of tried to cover it up. The Russian government now has been quite open about what's going on. Well, actually, it's the Ukrainian government that owns Chernobyl now, and they're pretty upfront about it. Although they're still arguably claiming that the number of deaths is radically lower than most people are estimating. But I'm curious. A large area was basically sterilized as a result of Chernobyl, and although they're doing tourism into there now, which just blows my mind. But how much of Japan is going to be sterilized by this? And have the prevailing winds in Japan, have they had the good luck of having continuous westerly winds at least keeping it off land. I realize it's a disaster for the ocean too, and I don't mean to minimize that. But have thoughts on this?
There's still a tremendous amount of radioactive inventory in that facility. I mean, what's not really been mentioned but once, I saw one Japanese account of this, but there is a common fuel pool to all 6 reactors that also lost power. And there is a tremendous amount of radioactive inventory in a pool that at one point was submerged by the tsunami. The building under 45 feet of water. I mean,
is this an in-ground pool?
It is an at-grade pool. But it is common to all. It's located between units 3 and 4 but it is a common pool in a building. There are about 2,000 fuel assemblies in there. I mean, I can't give you the weight on that just yet, but there's more nuclear waste there than in the fuel pools clearly at the other 6 units, and nobody's talking about it.
So there's actually 7 waste pool
but number 7 is gigantic.
Wow.
It is, and again, it is the pre-staging for loading this thermally hot and extremely radioactive waste into dry cask, which I've not heard of. They didn't have that many. Most of the fuel, most of this nuclear waste is still in that common pool, but they'd loaded some small number of casks that were then to be shipped off for interim storage or reprocessing to get the plutonium. But this, it is possible that if this thing continues to unravel and you get a site that becomes extremely more radioactive as they go, to 11, let's say, with these other reactors, then it's like dropping a match into a box of matches.
Right. By going to 11, what do you mean?
That there really is no recognizable limit to the devastation that this could. Do you
mean that the scale that they just took it to 7 could go to 11, or do you mean that there are 11 radiation sources here?
We have an accident that is still occurring.
We just don't know.
This is Chernobyl in slow motion,
right?
Which gives it a Fukushima. I mean, we're still, again, when we thought 3 Mile Island was the worst thing, certainly I did in 1979 when I was fighting to prevent the construction and operation of Seabrook.
Right.
But then we got blown away by what Chernobyl offers, and now we're being Fukushima'd with something that is really not fully grasped yet in what it portends.
Yeah, and so we don't even know yet how much of the country of Japan, either in percentage or square miles, has been rendered somewhere between uninhabitable and just very dangerous.
There will clearly be, there is already a growing uninhabitable zone when the Japanese government finally acknowledged that they needed to go, farther out than the 20 kilometers. Now we're out to 30 kilometers for uninhabitable. It's very likely, Chernobyl evacuation, the Chernobyl exclusion zone is still growing, Tom. I mean, we're 25 years and that zone is still building. These things portend the devastation not only in terms of distance, but in terms of time as they grow and worsen and present just how inherently dangerous this technology is.
The nuclear emergency at the Fukushima plant in Japan could be approaching historic proportions. The French Authority of Nuclear Safety set off warning bells around the world when it declared the Fukushima disaster to be the 2nd worst nuclear accident of all time. The Chernobyl disaster in the Soviet Union was at a level of 7 out of 7. That's pretty bad. 3 Mile Island, the worst nuclear accident in U.S. history, was a level 5 out of 7. ASN experts say, in their opinion, Fukushima is now at a level 6 out of 7, worse than 3 Mile Island. But what exactly does that mean? You've probably heard of both 3 Mile Island and Chernobyl, but do you remember exactly what happened? It was a long time ago, so I think it helps to refresh the facts here, and these are the facts. 3 Mile Island is a nuclear plant near Middletown, Pennsylvania, about 10 miles from Harrisburg. In March of 1979, the cooling system malfunctioned. The plant suffered a severe core meltdown, but it did not breach the containment structure. Some irradiated gas was vented from the plant, and pregnant women and children within a 5-mile radius were told to evacuate. On the 4th day, there were new false fears that a hydrogen bubble had formed and that it could cause the plant to explode, which caused widespread panic, understandably so. But experts quickly determined that an explosion wasn't scientifically possible. The size of the bubble was reduced and the crisis ended. No one was hurt or sickened. The Pennsylvania Department of Health kept a register of 30,000 potentially affected people, but luckily found no evidence of long-term health effects. Now, Chernobyl was totally different. Chernobyl was a nuclear facility in the Ukraine, part of the former Soviet Union, about 430 miles from Moscow. In April of 1986, a reactor exploded. The reactor had no emergency containment structure, which is insanity. As a result, it released more than 400 times more radioactive fallout than an atomic bomb. If you think about that, that is unbelievable. The explosion itself killed 2 workers. 28 emergency workers died within just 3 months, and that was mostly from acute radiation sickness. In the end, 200,000 people were evacuated and relocated entirely. More than 1 million people in 3 countries are on a national register as potentially affected by radiation. In fact, about 4,000 cases of thyroid cancer have been diagnosed in people who were exposed as children. Resettlement to the outermost containment areas began last year, almost a quarter century after the accident happened. So what will be the fallout of Fukushima? What will that be like? Obviously, there's a wide gulf between the severity of 3 Mile Island and Chernobyl. So what are the long-term threats of radiation and contamination in this case? Well, my next guest can help answer those questions. Joining me now is nuclear reactor specialist Ken Bergeron. He did research on nuclear reactor accident simulation for Sandia National Laboratories in New Mexico. Well, let's start talking about where this lies between 3 Mile Island and Chernobyl. I mean, they say 5 out of 7, 7 out of 7 is somewhere in between, but there's a huge gulf in between. Where are we at this juncture right now?
Well, the accident hasn't progressed to the point that the reactor core has been released from the pressure vessel, and that makes it far less bad than Chernobyl. But on the other hand, it's a lot worse than 3 Mile Island because, for one thing, there's 3 reactors involved. For another, since the containments at these reactors are a lot smaller and less capable than the 3 Mile Island containment, they have had to vent a considerable amount of reactivity in the process of depressurizing the containment. So there's been a great deal more release.
Yeah, well, Chernobyl was, as I said, insanity because they didn't even have a containment structure. Obviously, the Japanese have containment structures here, and they have held so far. But what happens if there is a meltdown? Then would it approach anything near Chernobyl, or still that wouldn't be the case?
Well, in terms of spectacular energetic events, it will never be anything like, none of these reactors will be anything like Chernobyl. They don't have the mechanism for that neutronic excursion, that atomic bomb-like explosion that occurred there. But in terms of health effects, I'm sorry to say it could be worse.
Really?
Having the release at ground level as opposed to this incredible blast followed by a hot fire at Chernobyl will mean that the radioactive material is much more, where people live. At ground level, it would depend a lot on the weather, the wind directions, but it was actually fortunate for the Chernobyl event that so much of that radioactive material got launched very, very high into the atmosphere, to the stratosphere, in fact.
That's really interesting. I had not heard that before. So what does it mean to be at the ground level? Does that mean you can spread more, or it goes in deeper, and then you have to relocate the people because they can't settle there? What exactly is the implication of that?
Well, the biggest fear is that it will be lofted, the radioactive cloud will be lofted high enough that it can be transported to various population centers and then settle, either by gravity or through precipitation, rain or snow, and therefore end up having a very large dose right where people, very large deposition right where people live. You know, we're talking about this before the reactor vessel has even failed, but so it's real speculation, but it could be very, very bad.
Obviously, especially if it goes towards Tokyo, where there's such an enormous number of people.
If they are unsuccessful, if they don't get enough water in any one of these reactors, and the core material slumps to the bottom of the vessel, that's called an uncoolable configuration. And that decay heat in that fuel could cause the fuel to melt and eventually penetrate the reactor vessel steel. Well, recently there was a contingent of 800 workers at the facility, and Tokyo Electric made the decision to pull most of those people once the radiation levels got to some of the levels that have been seen. Leaving 50 behind, no doubt volunteers, who knew that they were taking their lives, putting their lives on the line, and I have little doubt that many of those people will die, and wow. That's a sacrifice that they probably knew they were making.
You know, that's an amazing story. We're going to come back to that story because those people are beyond brave. They're now thinking you're bringing in reinforcements, and they're looking at retired people to come in. And you see the clear implication of that, partly because they're experts, partly because they're volunteering at that stage. It's an amazing story of heroism. Ken Bergeron, we really appreciate your expertise tonight. Thank you for coming out and talking to us.
And just because people might not have seen it because it's in Japanese, this is a visual description of the liquid glass. I think they're demonstrating the role of the liquid glass in plugging the leak into the ocean, at least temporarily.
水ガラスにこの反応剤を入れています。入れてみます。もう瞬間にゼリー状に固まりました。これが固まったことによってですね、壁のところの穴が塞がったというふうにお考えいただければいいと思います。で、上山さんが持ってくれてるのが、はい、石が入っている水ガラスがまだ使われてない前、石だけになってますが、これは普通のお水です。これを流してみます。
下から水がこうジャージャー出てきてしまう状態ですね。
漏れてましたね。はい、これが後ろのパネルの最初の段階だというふうにお考えいただければいいと思います。で、今度はもう一つ、ここを置いてください。水ガラスを使った後、この部分に水が入ったとしても、このように漏れなかったと。
下から何も
出てませんね。これでなんとかこの部分がですね、固まったということになるわけです。
そこに穴を開けたコップに水を流すと、当然水はこぼれる。では水ガラスと硬化剤を同時に投入した場合は、実際に水を流してみると、
ご覧のように全く水が下に流れていきません。